All right, welcome back. We are COMP1115. That's Game Programming 1 in the fall 2025 semester at Georgian, and it's week 5, part 1 of our broadcast and recording together. And in this part, last week we talked about loops, and this week we're talking about arrays, and next week we're talking about strings and string methods, and some debugging techniques we're going to be using. And then we're going to get right into our midterm test, which is like 2 weeks from now. Midterm test is going to be, like I mentioned last time, in person only, right? So no remote, unless you have an accommodation where you can write your, if you choose to, you can write your test in the test center. Hopefully that's going to be okay. I will find out. And then what we're going to be doing is, it's worth 20% of your final grade. You'll be getting a paper test to read, but you're going to be doing it on your computer. So whatever the test tells you to do, you'll execute those tasks on the computer. And then things that you need to know for the test: you need to have your student ID. So if you don't have your student ID, go get it, right? So you need that. You're going to sign in when you come in. You're going to put your bags at the front, right? No phones are allowed on your person, all right? So you're going to put them in the bag, right? All that kind of stuff. If you have weird things like smart glasses and smart watches and smart rings and all those kind of weird things, leave them at home, okay, if you can. Wear regular glasses that day, okay? Yes?
Wait a minute, student ID. Does this mean we have to have a one card?
You should have a one card. Yeah, so it means you have to get one. You have from now until week 7. You have 2 weeks to get it if you don't have it now.
Okay, I have never gotten a one card of it at any point in my time at any. Hold on, let me try it. I have never at any point, if I ever attended this college, I have never gotten a one card. I felt like I never needed one.
Now you need one. So let's move on.
That's not fair.
No, it is fair. It is fair, because I need you to get one, because that is going to be your ID that identifies you as who you are. Yes.
Where do you get a one card, sorry?
You get that right from the student center, right, in the C building. Okay. All right, let's continue. So, arrays, strings and string methods, all that kind of stuff. So last week we talked about whiles, do while, and for loops. We also talked about scoping and loops. Scope and loops are the same as scope and if statements, right? The same things. Scope, remember what it is variables live and die in a box, right? In this area, a container, right? That's what scope is. And so I always think about scope as like, variables can't escape when they're created in there, right? So we also talked about break and continue and how that breaks you out of the loop, or continues you back up to the top of the loop. It kind of short circuits the loop in some ways, right? Try parse we used last week to basically do some input validation to make sure that we got proper input from the user. And then we did a brief, is this right? Yes, we did methods, right? And then this week we're talking about arrays. And arrays are another foundational building block, right, as you continue to learn programming. They can be challenging to wrap your mind around if you've never done them before, right, to some degree. And there's a myriad of ways that we can declare arrays and use them. We'll talk about that today. So lots of stuff you can see. Last week I also asked you guys to do branching. Did you guys do your homework? Because we're going to be using it today, right? Branching was something that I asked you guys to do. If you remember from last week, I was going to bring that PowerPoint up from last week, right? So we said there was a point where it was here. I said there's some homework for you guys, branching. And one thing I asked you guys to do is review what branching is, right? Which is basically the ability for us to, as we're making commits, we're going to create a feature branch and then merge things back onto main. I'll be using this today, right? So my expectation is you would have read this, understand when I use my commands what they are, get branch, and so on. And then this is an example of what it would have been if I was going to make the feature. So once you make the branch, that's the first thing. And then when you do is you have to, when you do this, you have to check it out. So you can make the branch and check it out. There's also a shortcut that you can check out and create the branch at the same time. We're going to do it one step at a time, but there is a way of doing it in one. And then what happens is when you merge things back in, you check out main again, and after you check main out, then you merge everything back in. That's the way it goes. So it is definitely this way. So you kind of chomp along. You've got to this point now where you've got some commits in your past repo, and then we're going to merge back in after we create a branch. So we're going to do this kind of thing because when you work with other students to create your project, you may want to create your own branch so that you don't corrupt anything that's going on in the main branch. Now, there are some things that can happen when you're branching and merging, which are merge conflicts, okay? And that's where you have to decide which changes to keep sometimes and which ones to discard. One thing that we're also going to be talking about probably next week, if we can get to it, is making a pull request. We'll see how that goes. All right, so that is stuff we're going to be talking. We're going to be using branching today, branching in practice. So hopefully you read that part because we're going to be using it. And if you ever have a question on how to do that, always refer back to that other PowerPoint. Any questions before we begin, other than, do I need a one card? Because you need a one card. You need your ID for next for 2 weeks from now, so make sure you have it ready. It's not acceptable if it's on your phone, because you're not going to have access to your phone. Now, here's the thing about not having access to your phone. A lot of us we'll need to create a GitHub repository, right? We will need to do that, and sometimes you need your phone to log in to your GitHub for the first time, right? So what I may do is, whether it's next week or whether it's the night before or something like that, I'll get you guys to create an empty repository from home so that you don't need your phone, okay, when you're creating it, because you need two-factor authentication for GitHub sometimes, and then that'll be a problem if you can't do it. Other things. Next week is supposed to be remote, like we said last time, so you can see that next week is a remote week. That's the plan. I will be here in person like last time. I know that some people prefer to learn in person. Again, I will broadcast on Zoom at the same time if you prefer to be at home. But I found that last week when we did it, there was quite a few people here, and I think it was better for those people than for the people at home. I don't know if that makes any sense, but that's how it was. Yeah. So that's, I'm going to continue to do that. There was enough people last week in your two sections that warrants me to come in. Like, it wasn't like a small amount of people. There was like, I would say half of the people were here and half were online, which is pretty good, right? So there's enough interest, I think I'll continue to do that. All right, let's move on. Arrays. Yes, my friends, we're at this point now where we are building on everything that we did before. What are they? So imagine we have a bunch of stuff like this, right? And we have score 1, score 2, and score 3. And this is very bad form. Why? We're repeating ourselves. Remember last week we talked about do not repeat yourself, the dry principle, right? And we're definitely repeating ourselves here, right? There's a way easier way to do this. And how do we do that? With arrays. Arrays are like a collection of values. And what we're going to do, instead of having like multiple variables like score 1 and score 2 and score 3 and so on, we have one that's called scores, and it holds everything. All right, this is the thing that you have to think about. What it does is it creates these contiguous memory locations. I want you to think about them as little boxes. Imagine I have like this container here like this. Let's make a container. And then let's suppose I have, here, let's do this again. Let's make some more boxes. Okay, so I have a box, that kind of goes here, right, as an example. And that's the first memory location. And, we have another box. I'll kind of copy paste that one, and that'll go here. I'll put it right next to it, but not quite touching, just to make sure you can see it, right? And another one that goes here, and another one that goes here. Wow, this is actually panning out pretty good. PowerPoint is not so bad when you want to draw stuff. And let's make some more room. Maybe another one over here, right? So we have like some these boxes. And imagine these boxes are locations in memory, right? In your random access memory, right? Or RAM. So that's like volatile memory. RAM, when you turn your computer on, remember, you can hold stuff in there, and when your computer goes off, poof, it's gone, right? And when you turn it back on, it's reset, right? It's volatile memory. Non-volatile memory would be storage, like on your hard drive, right? So where you can retrieve that memory or load it back into volatile memory again. So you've got all these boxes. Imagine if each of these boxes, let's say the first one, now they're empty, but let's say in this first case, as an example, this box, we want to put something in, like a number, right? So we put it like a number like 12 in there. Let's see if I actually can see that number. PowerPoint. How beautiful you are. Right? 12. We have the number 12 in the box, right? So I set up a value of 12. And let's suppose this box, this whole big box, this outer box, this container has a name like scores. Let's take that scores name, and that's right here, all right? So this is the scores array. The scores array right now only has one value, the number value 12. Woohoo, right? Very interesting. The other values, although we have spaces in the array for another 4 values, those values are now empty. So when you declare an array, what you're actually doing is reserving spaces in memory, right? That's what I'm doing. When you allocate those spaces as we assign values into them, right? Then what ends up happening is, the spaces become full, right? So these spaces, also called, kind of memory locations, right? I'm just going to copy this thing for a second to show you. Again, think about this as my little whiteboard, like I'm drawing on the board. And I hate chalk, so that's why I'm doing it like this, okay? Let's suppose this memory location is memory location 0, right? And by the way, like always, even though I have 50 PowerPoint slides, I'm not going to read them. I'm just going to do something like this, and maybe even work with our friendly neighborhood Visual Studio very soon too, right? Because, it's just far easier and way more exciting than watching me, type stuff up on the screen. Okay, so let's suppose this is the scores array and this is memory location 0. And normally, what you would expect is that you'd start counting by memory location 1, but not so with arrays. And one thing that I got to talk about is this idea of zero-based indexing. That's what it is. So C-influenced languages like Java, C#, C++, JavaScript, and so on, all start counting at 0, okay, not at 1. Okay, so just letting you know that. And what that means is that students, when you're first learning about this, get a little bit freaked out. They're like, wait, how come it's 0? Kind of thing. Why don't we start at 1? There is a language, however, that did start counting at 1. They're phasing that language out. It's called Visual Basic, right? And Basic in general starts counting at 1. It's phased out. It's phasing out. But for the most part, when we talk about how to, what the address is of those parts of the scores array, we can say scores 0 has a value of 12, but scores 1 has a value of nothing. There's nothing in those spaces. All right. Now let's suppose that scores holds variables that are of integer type. We have to specify each array can only hold the same variable type. Okay, it can't hold like some strings and some booleans and some floats. It can't do that kind of stuff. It can only hold the same memory types. Why? Well, remember that each memory location is the size of your type, right? Some types are longer, like bigger, like floats are much bigger in terms of memory storage than integers are, and so on, right? So if we did that, then I couldn't have equal numbers. It wouldn't look the same. It would be like one was larger, one smaller, and so that would be really messed up when it comes to how each of the arrays are set up in memory, right? Because it'd be like weird, right? So we don't do it that way. Typically for arrays, they're all the same size. That's what they are. Okay, all the locations in memory are the same. Contiguous means that they're next to each other in memory, and what this means is it's super fast to access because I don't have to skip around. Sometimes when you allocate memory on the machine, wherever it is, it might be in different places, and you have to kind of go from here to here and to here. You don't have to do that here. With arrays, they're right next to each other, all right? And that's why they're very, very fast, right, in terms of access. So, again, yes?
So for RAM timings, like CL26 versus 36, like what determines the speed and latency of the RAM?
It can make a huge difference. It can make a huge difference. The closer your RAM is, actually there's two parts, right, when it comes to speed, right? One part of speed for memory is how close it is to your processor, right? So physically, hardware, I'm taking, right? If you have a piece of RAM and it's like closer to your processor, and notice that they are close, right? You actually, your RAM, if you actually have, you look in your machine, that's how they're positioned right next to it. If they're far away, right? The farther away is wires have to travel much farther latency, and the faster the RAM is, it's been created for the lower latency RAM is better for gaming because again, you're transferring memory from here to your CPU and back out to your GPU, right? But anyway, that is a topic for another day, right? But the point is that yes, that is part of it. But what we want to do here is I also want to talk about this idea, and I want to talk about this idea of, here we go again. So we have this, but imagine, you know, that I haven't done anything with these memory locations, right? So these memory locations here, right? Let's see if I can do that same little trick. Maybe I cannot. Okay, well, we're going to do it again. That's what happens when you have PowerPoint and you don't have these. I'm just going to copy paste these. Haha. So let's suppose these memory locations. Wow, so inefficient. They're 0. I haven't allocated anything to them at all. If I don't, because I'm creating variable an array of type integer in this case. That's what scores is, because scores is, you know, so far we don't have scores that are like, you know, 1.2. Your score is not 1.2. Your score is 1, 2, 3, 4, 10. In this case, just from a context perspective, that means that scores is an integer type of array, right? That's what it is, an int array. And it's not one variable, it's an array. And so how we signify or signal that this is an array as opposed to a variable is we use these square brackets, right? So we say that square brackets say that that kind of tell us that this thing here is an array as opposed to a single variable. Okay, so this is kind of what you're going to see. You're going to see something like this in scores, and then what we're going to do is we're going to allocate memory to scores. So score 0 has 12, but scores 1, 2, 3, 4 is 0. There's nothing in them, right? Or they have a value of 0, okay? Now remember, because they're integers, if we do allocate memory, we could allocate them. We don't have to allocate them in order. We could say that scores 2 has a value of -3. -3 is still an integer. It's just a negative integer. Score of a negative number, that's kind of weird, right? So chances are we wouldn't have that. But it could hold a negative number if we really wanted to. Let's make a value of 30 kind of put into location 2, right? Each of these values here, each of these like spots, if you will, each of these spots are called elements, right? So again, we're going to go over this again. So I have a number of elements. I have 5 elements inside of this scores array. That's how we talk about it. 5 elements. There's the 0th element, the first element, the second element, and so on. 0th is an actual thing. Okay, I'm not lying, right? So yeah. So if you're confused, right? Terminology. I'm trying to you know, kind of share terminology with you. So when you talk to other programmers, they know what you're saying, right? The 0th element is a thing. That means this, if I was going to talk about it, is the 0th element, right? This is the first element, and so on. Okay, so again, the most important thing to note is that everything starts with 0, no matter what. When you make an array, it's 0-based counting, or 0-based indexing, if you will. Okay? So again, you don't have to put stuff in every location together as an example, but you can allocate memory and read and write from it, you know, the way you would normally any other variable. So one thing is this, okay? When I allocate memory, when I create an array, okay, and I allocate memory for the first time for that array, I can never add more locations. As soon as I add them, if I say that the array is a size 5, like what this is, that's why I purposely did 0 to 4, It's a size 5 array. There's 5 locations starting from 0 to 4, right? I can never have 6. Once I create that array, it's there forever. It's immutable, okay? It's unchangeable when it comes to how many locations it has. So that's something that we have to really think about. Arrays are immutable, okay? I'll type that word. Okay, I can't change them, right? However, I can recreate them. I can destroy the array, wipe out the memory, and make more memory. I can do that, but I can't add memory cells. I can't do that, okay? It's not allowed, so it's immutable. So that's the kind of way that it works, okay? Questions around this so far? Anyone confused? Because this is the basic things about arrays. After this, it gets all hairy, because it gets like, we're going to start programming and trying it, okay? So each position, there's an index involved. That's what they're called. The index 0, or index 1, or index 2. Those are the way it works. There's the beginning of the array, and there's the end of the array. All right, this array has a size, right? And one thing that we can have a problem with as well is if we go out of bounds. So example, if I try to access scores 5, scores 0 exists, 1, 2, 3, 4 exists, but 5, no, that doesn't exist. Then your computer program will break. You cannot index or access a location in memory that's outside the bounds of the declared array. If I make an array of 5 locations, then all you have is 5, right? If I try and access the 6th location, it's going to cough up some blood, all right? You're just punching the computer in the head. Don't do that, all right? It's a bad thing. All right. So we create arrays like this, like we said, all right? So we do that with square brackets. The square brackets actually have a name, okay? They're actually called the index operator. All right, that's what they are. They're actually operators. All right, that's what they are. Because we can eventually one day, maybe next semester, depending on what Wallace will do with you, you can override them. All right, but that's for a topic for another day. Different kinds of array. You don't have to make an integer array. That's for scores, but you can make a string array, a bool array. You can make any array of whatever type you need. Okay. When you declare an array, you need to use the new keyword. Okay, that's a new thing. New. What I'm doing with new is I'm creating, and this is a crazy word here that we're going to get, I'm going to instantiate an object of type integer, all right? All right, so this is where we're starting to get into it. The new keyword, what it does is it creates the array, all right? So not every language needs the new keyword. C# needs it, all right? Java needs it. Even JavaScript needs the new keyword as an example, and it allocates memory. If you're going to just allocate memory, what this is doing here is it's giving us 10 locations for the scores array. 10, not 5 in this case. Yes.
Okay. From what you just said,
Uh-huh.
if it's creating 10 new locations, I assume that's 0 to 9.
Correct.
Okay.
0 to 9. I was just going to say that. Great, you're getting it. I'm creating 10 locations, 0 to 9, not 0 to 10, okay? 10 is not included. It's 10 locations starting at 0, right? That's how it goes, 0-based counting. So I make 10 locations, but there's nothing in them. When I do this, new int, it just allocates spaces in memory. That's all it's doing. The memory is empty, or it has a value of 0 because integers, by default, have a value of 0 when you're creating them, okay? Every variable has a default value when you create them. Some of them have a null value. They have no value, okay? But for the most part, primitives like floats and bools and integers, they all have a default value, a starting value, right? Whether you allocate something to them or not, okay? So again, we talked about that you cannot shrink or extend the array. It cannot be resized. Here's an example. If I was to do something like this again, I would wipe out the original memory locations, the 10 that I allocated. I wipe them all out, and then I'd start over with 20. You can do that, right? But all the data that you had stored in those 10 locations are gone. It's gone. It's just wiped away. It's like you're literally clearing the array, okay? And I'm doing this first before we start, just to get you guys to understand the basics, and then we'll get into it, okay? So the index operator, all right? So here's an example of when I allocate, when I save memory in the array. I can specify which location with the square brackets. The square brackets tells the computer which one of those places inside the box, which one of those places you're accessing. I'm accessing location 0 inside the location. So you can think about this as an address. Another way that I've talked about this is these are houses on a street. And each house on the street has an address, 0, 1, 2, 3, 4, and so on the street, okay? And so we're saying, well, house number 2, you know, it's actually the second house, but it's actually the third one, right? It just, the memory location, the address on the wall or whatever in the house, maybe in front of the garage is 2, right? But that's how you would access it. And when we come back to this part, that's exactly what we're doing here, where we're saying score 0, I want to allocate, I want to assign a value of 99 and put it into score 0. That's like me doing this. Go here and put in 99, okay? That's what I'm doing there, okay? So you could also do some arithmetic, all right? Like it will resolve just like normal. Something like this, like whatever the spot is, if I said something like 0 plus 1, I mean, that would be 1, right? So it does evaluate expressions inside the square brackets. So if you wanted to do some kind of calculations to figure out which number you want to put it into, that can work. All right, we talked about zero-based indexing. So you can do the same thing with the other ones. You can say like, scores number 1 is number 95 and number 2 is 90. So again, if I was going to be back here, I could say something like, I'm going to put 95 there. If there was something there already and I do it, I just replaces it with what I have, something like this. And this is kind of what it would look like, okay? If I'm allocating memory, to those locations, which I'm doing here, okay? If I want to read the location, I want to read the memory, that's writing. This is how you write to the location, and this is how you read from it. If you just allocate it like this or access it like this, you're actually reading from location 0 when you don't have something like this, just like you would with a variable. If I say like, print out this variable, it's the same thing here. I'm printing out the value of scores 0. Okay. You guys are fading away. I have to talk about basics. I'm sorry to do this first before we do stuff in Visual Studio, but I need to do this because when we get to it, I'm going to do it, and you're going to be like, wait, what is he doing? Right? That's why I'm doing this with you first. I'm priming you up a little bit before we do this. Okay, let's get into the in-class exercise. What I want to do now, like last week, before we continue, is I want to clone my previous repository, and I want to rename my project just like last week. That's part of your in-class exercise. What I want you to do to get you ready for this is I'm going to do it without you. You're going to do it by yourself. I want you to download your project from last week, in-class exercise 4, right? And I want you to rename it to in-class exercise 5 and all the stuff we did last week. Let's see if you can remember it all. Okay, go. I'm going to wait. Huh? You don't know how to do it?
Mine broke last week.
Yours broke? Okay, we'll do it together. Fine. So here's how you do it. Let's suppose I have a project last week called ICE4. This is my ICE4 project. It's on GitHub, okay? And let's suppose I do not have it with me. I don't have a folder on my computer that's ICE4. In fact, I don't. Last week, remember, I had some problems with my little computer here, right? And I only have up to ICE3 because I used my laptop last week when I was here. I was broadcasting from my laptop. I don't have it here, so I have to download it. There's no other way. So the way to do this is, there's 2 ways to get this ICE4. One is to just simply download it. If you just go here and download, you can download the zip. The other way to do it is to clone this thing. Okay, so what cloning does, if you remember, is it copies everything from ICE4 and keeps my commits. Notice I have 8 commits, right? There's some from the previous week, and there's some from last week. 3 from last week, a bunch from the previous week. I want to keep these because this is a history of all the changes that I made to my little application that I've been building for the last few weeks, okay? I don't want to lose this stuff. I would rather clone than download. Downloading, there's no commits. You just get the files. That's what you do. All right. So what I want to do when I clone is I want to be able to copy this link, but I need a location for where I'm going to clone things to. All right. So back to this. I can't clone in here, right? Well, I can because my name of my repository is this. It's not ICE5. It's this or ICE4, right? But if I had this, if you, for whatever reason, called your thing ICE4, you could not clone in this folder because there is already, sorry, ICE3. If the ICE4 existed here, then you would already have it here, okay? I don't have it there, so I can simply clone mine, okay? Now you can try, let's putting it just to make it even, like imagine I have it here. I'm gonna put it somewhere out here. So I'm not gonna bounce with something else, okay? And let's just get rid of this one. Okay, so I'm going to put it out here. So this is how we do it. I'm going to go to my folder. If you can, I'm going to right click and I'm going to, you can open up in terminal. If it doesn't allow you to, and mine, in this case, does not allow me to open up in terminal, see? Then you can simply pull up your command prompt by typing in CMD, yes?
I just mentioned another shortcut for CMD there in your File Explorer. If you go back to the File Explorer, if you click up top where it has like the downloads Georgian and pull it up as like a
yes, I know.
Yes.
Yeah. You can do this, you mean, right?
Yeah, if you just type CMD there, it loads up directly into it loads the command prompt at that destination.
It's awesome. It's actually a really good way of doing it. You're talking about like CMD this, like this?
Yeah, even if because you can just clear out the thing and just call CMD there.
Yeah, this is definitely a way of doing it as well. That's a really nice way. Thank you for that. And so what that is like, because, okay, let's go back to this. So normally what you have is breadcrumbs. You have these little links here, right? And so what you can do is if you right click, you can expose this as an address instead. That's definitely a really cool way of doing it. And because we have our address, instead of you hunting and dragging and dropping here, you can just put in, because this is kind of like a little command prompt, you can put in a little CMD right in front and press enter, and then it'll just open up command prompts right there, okay? So you can do it that way as well. The other way that I like to do it, like I showed you guys last time, is if you're in your G drive, if you're using the machine in front of you, you can switch to C. That's the first thing you have to do, switch to your C drive. And then what you can do is you can drag and drop into, if you just go back up one level to here, you can just drag and drop into Georgian. If I do CD space like this, it's a little bit more work, but I can do CD space, drag and drop into this, and press enter, and it's the same thing. All right, so it's really up to you how you get here. Doesn't matter to me, right? But let's suppose I'm going to use this one because it's big, so you can see it, right? And I'm in the right folder. I know that. However I got here, whether you did it the other way that we just talked about, or whether you did it my way, which is dragging and drop, you have to be in the folder that you're looking at. Even if you right-clicked and said open in terminal, sometimes it'll allow you to do that as well, right? I'm right in here right now. I'm in this folder, right? This is the location. So that's me, my downloads folder, inside the Georgian folder. That's what this is basically saying, okay? So I'm in here right now. Okay, cool. So now that I'm there, I'm going to issue the command. Yes?
I'm trying to figure out a way to clone the thing with the link.
I'll show it to you right now. Here we go. So I'm going to type in the word git clone. Git, or this is the command, git clone, right? Hopefully you guys can see that. Maybe not. I'll make it a little bigger. Properties. Let's go with 72. Woohoo! That's too big. That's way too big. I can't even work like that. Is there another number I can put in here? Like maybe 45. How about that? 45. There we go. Git clone. All right. How about this? Yes.
I can't really do anything more than simply copying the URL to clipboard.
You need to do this. You need to do this. Type in git clone space, and then once you get the URL from the clipboard, which is here, you go here into your previous repository, and then you go in here to this little code button. There's a little copy to clipboard, copy, and when you go back to your command prompt, if you right-click, it pastes it in. Okay, that's what it does.
I think I'll just make a brand new repository.
No, you won't. You're going to do what I'm telling you to do, right? Try it out, buddy. You're going to be okay. Making a brand new repository is not what I'm asking you to do. You'll lose marks. Don't do that. Can,
nothing is doing anything for
can
me.
someone give him a hand, please, so we can move on? There's some
Yes,
people next to him.
please. I don't want to keep going through with this and have to deal with all this.
You're going to be okay. Don't worry. All right, so now that we've done this, and if I was to press enter, the rest of you guys just press enter here. What you're going to see is a bunch of stuff happen where I'm cloning my repository to my folder. That's what happens, okay? And when I go back to my folder, you can simply see that I have my in-class exercise 4 downloaded. Yes?
So if we have a folder called S4 already, should we clone it outside of that?
Yes, please. Or else, like I said, if you don't do it that way, it'll try and clobber the other folder, right? And that'll be bad, right? Okay. So now that I have ICE4, I've downloaded ICE4, I'm going to rename this to ICE5. I'm just going to click here and rename the outside folder to ICE5. There it is. And there is the inside folder here, but I'm not going to rename it right now. I'm not doing that yet. Okay, I want to open this thing up in Visual Studio and do some of the stuff from inside Visual Studio. But before I do that, I'm going to cut this out of here and put it in the right location, like here where all my other ones are. Okay, here it is, right? Okay, and then I want to open up Visual Studio. So let's do that. So I'm just going to double click on the SLN file that's inside of the ICE5 folder now. Double click onto it, and then it'll open up Visual Studio where we left off last week. Minus your changes, because you made some changes. You're supposed to do some stuff for me last week, right? And now I might give you something like this. WSL is not installed because it's supposed to point to ICE4 here, right? So that's the thing you're supposed to do. Let's just X out of this. Your Solution Explorer should be open. It might be hidden. You maybe want to open it and pin it. There's a little pin icon here. And when you open it, you're going to see this, right? This is my program from last week, okay? I'm just going to delete that. Yes?
So once we've cloned it, we move it to the...
Yeah,
Okay.
move it to the appropriate folder.
Okay.
But there's a problem, right? Because I'm missing some stuff. You have some stuff, and I have other things, right? So, you know, I have some stuff that you don't have. Where is it all? Okay. By the way, what happens if you can't do anything? Like you can't delete anything, you can't move anything. What does that mean? Have you guys tried that? Have you guys tried to like add or type or whatever, and then it's preventing you from backspacing or something like that? Is that are you having a problem with any of that? Good. Because that would be very bad. No. You should definitely be able to do everything. I just can't. I don't know why I can't, but that's neither here nor there. All right. So I'm going to. I can't even like do a command, man. All right. Maybe it needs me needed me to save. Okay.
For some reason my code is like completely empty. But
Are you sure? In program.cs it's empty? You have to open up ICE4 and you have to go to your Solution Explorer and double click on program.cs and you're good to go. Yeah, it's there. All right, so last week what we did was, I'm just catching up. Last week I did this, and notice one thing that I asked you guys to do was replace all this stuff with a random function. So one of the things you guys had a problem with, you can catch up, right? One thing that we had a problem with last week, right, is, and I gave you guys feedback. Everyone's got their marks from last week who submitted. My feedback was it's inefficient, right? You can't make a function inside of while. Why is that inefficient to put your function inside of a while loop? Yes?
It's only usable within that spot.
That's one reason, but what's the other reason? I want you to think about this really clearly. What happens in a scope? All right? Huh? It lives and dies in that scope. What else happens in that scope? What happens in a while loop scope? What happens? What am I actually doing in the while loop? Every single time I loop through it. Take a look at this, man. If I go up to the top, look at what I'm doing. There's some other stuff that's inefficient too, by the way. Here's stuff, all right? Agility, right now, all these things get recreated. All this stuff gets recreated. All this stuff gets recreated. All this, which I'm not really using, gets recreated, all right? I get all that stuff that gets recreated. All this gets redone. All of this gets redone. All of that gets redone. And if I put my function in there, it gets recreated too. Functions are stupid heavy when it comes to kind of instantiating. Okay, you do not want to on the fly instantiate functions. That means like actually allocate memory for functions on the fly. Like I'm like actually creating them in real time. That's terrible, right? Yes.
Do the functions affect the code if they aren't like properly done and like corrupt something?
It's not that. It's just that if you put it inside the while loop, in the while loop, you're in the middle of your iteration, you're creating that function. You're allocating memory, right? Now imagine if you're playing a game and doing that, right? Like it's like you're literally just going whoop, 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 whoop. You're just doing one of these things every single time. You're increasing your memory and slapping it back down. What you're going to get if you're playing a real game like this, right? If you do something like that, you're going to get these spikes of performance, right? Where it's like, okay, I'm really great. I've just deleted everything. Okay, I'm really terrible. I'm really great again. I'm really terrible. And you're going to get like this terrible, like, skittery feeling to your game if you ever make something like that. Oh yeah, it's terrible like that, right? Because you're going to get all these memory spikes like this. That's what's happening. So it's stupidly inefficient to do that. And it's not because you guys are dumb. It's not that way. It's just that, you guys got to think about inside of a while loop. What would be worse is if you put it in here, like in the inner while loop. Okay, that'd be even worse, right? You want to put it outside of these things, out here, so outside of the while loop up here, or outside of the while loop down here. I like putting my stuff down here. This is outside the while loop, right? Somewhere in here. Okay, it's inside. Let's take a look. You can track these little lines. These little lines show you the opening and closing braces, right? So you can see if I follow this, this is inside the while loop. Here, this third brace is outside the while loop, right? This is outside the while loop right here. So this one's outside the while loop, and here is still inside the while loop, okay? These braces have little lines. These little lines tell you where you are. Each of these curly braces is a box, right? So I want to be here, outside the while loop, right? And I want to create this function, right? So I'm going to make this local function. This is what you're supposed to do. This is last week's homework. I want to make a local function, right? And you already have this. Don't do it. I'm just showing you what I'm giving you a solution for last week. Okay. I'm going to make a roll 5d10 function. That's what it is, right? And in the roll 5d10 function, it gives me an error because when I have this in front of it, what does it mean? What does this mean in front of a function? Yes?
Return type. So when you call it, it's going to send back an int number.
I must return something. If I say something like this in front of a function, I must return. It's not an option, okay? Otherwise, it'll error out. I need a return type. So I want to do what I did last time. I want to declare a little variable called total, let's say. I can allocate 0 to it. I can do a for loop, right? Where I want to put my die is equal to 0, where die is less. You don't have to do this if you already have it. Where die is less than 5, right? Then die plus plus. I can do that. Die plus plus. Right? That's what we had last time. And then what I want to do is I want to say that my total, right, is plus equals to, some kind of random number. Now, right now, my random number is stuck here. This is where I put it. Remember, this is also part of another scope. I cannot access this thing here. Can't access it, which means I have to take this part right here and put it somewhere where it's always accessible. If I want to make this accessible to the entire main function, where should I put it? Outside of the loop. That's where I should put it again. So I'm going to grab this thing, right? And I'm going to kind of put it way at the top up here, like here, okay? Now let me explain why I don't want to put it here. Okay, I could put it inside the function, but if I put it inside the function, remember what's happening here. The random, go back up to that command, this random thing, when I use the new, I'm allocating space for a new random number seed, right? Remember, I'm not truly random. I'm using a pseudo-random number, which means I'm looking at a table. There's a table somewhere in memory, and I'm looking through it. If I keep accessing this every single time I roll a die, there's a chance that I'm going to look at the exact same table very, very quickly, which means I'm going to get no randomness at all. It's just going to be the same numbers over and over again. So please do not do this inside of a random function, right? Something that's going to generate it. Put it somewhere out here where you do it once, okay? Then when I go back to here, right, I can use it. I can say die.next, right, as an example, and then 1 to 11. That's what I want to do, right? Or not die, sorry. It's called, did I call it dice?
Oh, D10, I believe.
D10, thank you. Right? So this basically, kind of, adds everything together, 1, 2, 3, 4, 5, as an example. And then afterwards, I'm going to return. I must return my total. That is my function. And it needs to be somewhere outside of the while loop. Next, once I have my function, right, then I want to use it. So up here, there's a couple ways to do this, right? Some people just did roll 5d10, right, which is good. So roll 5d10, and I need to use brackets because when I call the function, I need to call it like this. And I simply can do the same thing over and over again. Okay, listen to what I just said, guys. I said over and over again. What am I doing here? I'm repeating myself. Today, we're not going to repeat ourselves. We're going to figure out a better way of doing this than what I'm doing right now, because this, my friends, even, is better, but we can do better. This is not good enough. All right? Yes.
So I'm assuming you want us to use scores to make that better.
We're going to do our own,
Wow.
Okay.
but yes.
Mine doesn't work.
We're going to do something better than this, but I'll show you what we're going to do. All right. So that is what last week's homework was. I've just finished last week's homework. I'm up to par with what you should have done last week, okay? Right now. Let me now rename my project so it's proper. So the first thing I did was just putting everything up to par, all right? And before I do this, I'm going to rename it. So I'm going to right-click here, and I'm going to rename it. So I'm going to go rename to ICE5. Here we go. There's ICE5. And I'm also going to rename, right-click and rename, yes?
Where's the sorry?
What?
Oh, you click up there. Okay. Sorry.
Yeah, I'm just going to rename those two pieces to ICE5. There's also a part here I need to rename. This says ICE4. I'm going to rename by going to ICE5 debug properties, this one here. And I'm going to rename this to ICE5. These are all things we did already last week, guys. By the way, this will be in the video. So you don't have to try and remember everything, but you should review it because you're going to need it for your test, right? And I don't want to use WSL. That's weird. I want to use ICE5, right? That's what I want to use here. And I want to close this off right here. Yes?
Sorry, for the play button ICE4, how did you rename that again?
I pulled it down and I went to ICE5 debug properties here, and then I renamed it here.
Okay.
Okay? All right, so now that I've got that, I want to run this code to make sure it still functions, right? So I want to run ICE5, make sure it still works. It should give me this thing right here where I can type in Tom, and I can do 6, and it gives me random numbers. And if I press escape, it gets out. It kind of comes out. I think it's working. This is good. Now I want to save all, if you're with me, and I want to close. Yes. Yes, the namespace is definitely something I forgot. The ICE4 needs to be changed to ICE5. We're just doing the renaming process, guys. Same thing we did last week. Going through the renaming process. All right? And once we've done this and we rename everything to ICE5, we've changed this. I've got everything up to par. I've added in my roll D5, D10 and stuff like this. And I've renamed this stuff up here, solution. I'm going to close down my Solution Explorer, save all. Close my Visual Studio down, and then now inside of my folder I'm going to rename the project folder here, ICE4. It's got to rename to ICE5. Now there's going to be a problem, right? Remember what we have to do. Once we rename this folder, we also have to change the stuff in the SLN file. We can right click and open with Notepad. If I go to Notepad or something else, I'm just going to go to Notepad right now. Okay. And what this is going to do is we want to change the reference to the ICE4 folder that I just renamed to ICE5. Right? Guys, there is no other way to do this properly. I wish there was. I wish there was a quick way of renaming the stuff and it would reach to rename everything, but the answer is there's not. Okay, so that's it. Now that this has been renamed, then I should try it again. All right, so I'm going to try this out, make sure that it works. I'm going to get this thing that shows me that, hey, there's a problem. Wow, what did you do, Tom? Well, what I did was I renamed you, so I should double click that again. And here I am and run it, and this is what we did last week. So then if I run it, and if I do number 6 again, you can see other numbers, and we're good to go. Okay? So now we're renamed. Are you with me? Just close that off. Close that off. Close that off, and then open up your program.cs again. Yeah, hold on. Close that off. Close that off. Open up your open up this. Yeah. Well, you didn't rename it properly, I guess? Delete something? Let's see. Go back to your folder. So close this thing down. Yeah, let's close it. So right click on your solution file. Go to open more. Open with.
Oh, I'm just like, that's not having, I'm just looking at all that, but I don't have it.
Two-year programming course. So it's like, besides the whole like values and everything, I've done like do it again. I host a
Yes.
for my
Yeah.
last week I even introduced a similar thing.
File save.
I did it on ICE 2 instead of ICE 3, but I introduced like
That's cool.
Right?
So
Because
this
you
is all
finish
like
naming it as a project. You still have this over?
To me, it's like
Alright, close that
literally
off.
like he's had like learned.
If it close off, you're going to just like not that.
It's so
Yes,
so
close it.
impressive. Like,
Now you're gonna be in
like,
trouble.
it's the, like,
Reload.
like the history.
Close it off.
Once you've done
Alright,
it like
now.
really deeply, like in one language, it
Double click on the
transfers
select
What
file.
languages you learn?
I started with Java in high school, and then
And what you want to do is you want to rename that solution, top solution, you missed that one. Right click and rename.
and then also because like, I wanted to
Almost there, guys. If you're watching the video and if you're just waiting for me, fast forward.
I'm gonna go to him first. And then so a lot of the stuff is stuff like I effectively self-taught on this stuff. There's some stuff that's not discoverable, that's definitely helpful, but yeah.
Just because like
Yeah, I would know the obvious you know, right or finish.
That's cool. What about are you doing the very stuff the same Kubernetes like with walls?
I might be the other section for that one because I like half section and half section too.
Oh, I see.
So like I'm in the Thursday art management opportunities. I have art first on Wednesday, math second. I'm in the 1 p.m. Monday course and the 12 p.m. Tuesday course. And then of course I'm here now.
Yeah.
So which if you just took one of the default schedules, I think I'm with you Monday.
I took like
I'm with you Monday, Thursday, and
What's wrong with you?
for the math? Like,
I got this.
Yeah.
understand like all the math as well?
more or less.
Oh, okay. Like I'm asking like have you learned that stuff as well?
I tried to in high school because it was grade 12 copies of the back home. But that was the course
There's no other way to
I
do it.
failed because I was just getting into the budgets and I thought of like I'm a hot shit, I know how to do math, and then I didn't understand anything.
All right. All right. So I'm going to take a break in a second, and I'm going to help people. Let me just finish off what I'm doing, and then we'll go on. So I've renamed my project, okay? I've renamed my project. And what I'm doing with the renaming now is, if you notice that everything works, I should test it to make sure that it's working properly. Here I am, right? So I can go here and do this stuff, and I'm all at this point right now. But I need to put this up on GitHub, and if I go to view terminal here inside of my Visual Studio,
It's not doing anything for me.
you need to wait, Damien. I'm going to help you. Wait till after. I'm going to go during break. I'll come over and help you out, okay? Bear with me. Thank you. All right, so inside of here, as you can see, right, if I do a get remote minus V, it's going to show me that I'm pointing at ICE4. It tells you that right here. That's what it's pointing to. I need to remove my remote, right? So the answer is I need to do a get remote remove origin. Get remote remove origin, or remove the origin remote, right? And if I do that, you're going to see that if I do a get remote again, there's no remotes. I have nothing anymore, right? That's what you should see. So if I did a get remote minus V, I'm going to see ICE4, whatever that was pointing to, and I want to remove it, and if I test it again, I got nothing, okay? So now what I need to do is I need to create a new repository on GitHub. So I'm going to go back to GitHub. Again, for those people who are behind, bear with me. I'll try and get to you at the break. I'm going to go to my GitHub. I'm going to make a new folder, a new repository. I'm going to, just like last time, like we've done it every single time, I'm going to encode mine like this, COMP1115 in the fall 2025 semester, and it is ICE5. Thank you, my brain. You're my brain today. And once I've done ICE5, I'm just going to go down here and create my repository. It's going to give me some steering instructions. I'm already private. It's going to give me some steering instructions that look like this. I'm going to copy them, and I'm going to go back to Visual Studio and right-click here and press Enter. That is the process. And if I did everything properly, I've pushed up everything now to my new repo. If I go back to my new repo and refresh, you can see that here I am, but I have ICE4 here. Why? We never did a commit for all the changes we just made. We changed, renamed stuff. We did all those things. We renamed everything, right? So I need to do another commit. So I'm going to go back to here to Visual Studio, and here's my commit. Git add dot git commit minus M for message, and we're going to say something like, you know, I can say either added project files for ICE5, or I migrated project files into ICE5, something like that, because that's what I've just done. I'm just going to say added project files for ICE5, right? And then that is my commit. That makes, look at what it's doing here. It's telling you, it says it's renaming from ICE4 to ICE5, from ICE4 to ICE5. It does all those things. It's telling me what I'm doing, right? And once I've done that, I can do a git push. And when I push back to GitHub, when I go here and refresh, you're going to see that here I have ICE5. And I have 9 commits. If I go back, you can see that I have a commit from this week. I have 3 commits from last week. And I have 5 commits from the previous week. I have all of my commits. This is what I want you guys to have. I want you to show you a continuous history of your development as you keep going, okay? So this is what you should have. And now I'm ready to do ICE5 with you today. Okay, this is the first part of ICE5. If you actually go to your last page here, or the last pages, starting around page 44, you can see the first part for a couple marks is what we just did. All right, so it is worth something to know how to do this, okay? It tells you what to do, right? So, you know, you need to be able to do that kind of stuff right here, right? And actually this should not say remove, it should say RM, right? RM, but that's the same thing, okay? And then we're going to be talking about making a branch. That's what's coming up next. We're going to do that next because we're doing branching this week, okay? But for now, we're going to take a short break. We're sitting at 9 o'clock and about that, and then I'm going to come around, make sure everyone's good. Can I get your help as well? Can you go around and help some other people? And then what we'll do is, between the two of us, we'll try and get everyone set up so that way everyone is up to speed. Okay? I'll take a short break, and we'll come back in about 10 or 15 minutes. It might be a little bit longer than 10 minutes because I want to try and help people and get a coffee. Oh yeah, coffee's important. It's liquid gold, my friends, right? So I gotta get my coffee. And when we come back, we'll do more of this stuff, okay?